Hello, and welcome to Fact-Based Living, the occasional vlog where we take the principles of science, logic, and critical thinking, and we show you what they are, what they do, and how to make your life better by applying them. I'm your host, Newton. Let's get started. For the first few episodes of the show are mostly going to be defining some terms and exploring some of the key concepts that we will use as a foundation for exploring science and the world around us. Oh, I see we already have a question. Yes, I am indeed a brain in a vat. Wanna know why? Ask this guy. He knows what he did. So now that that's out of the way, let's dive right into today's topic, which is science and knowledge. And first off, what is science? We all took science class in elementary school, and usually later on, right around middle or high school, science gets divided into separate individual subjects, things like chemistry or physics or biology. Yet even though most of us have taken science classes, it seems like many of us are still confused as to what science actually is. Well, the short answer is that science is any discipline that helps us gain knowledge about the world around us. Science is literally everything. I mean, to me, history is just as much a science as chemistry, but we just don't teach it that way. And that'll be the point of this series, to illustrate just how connected science is to our everyday lives, and how important it is for our happiness, our productivity, and often for our very survival. So if science is just collecting knowledge, we run into another term that needs clarification. So what is this knowledge stuff anyway? Well, philosophers have been arguing about this for millennia, and there are more definitions of knowledge than there are fish in the sea. Fortunately, I think I found a way to distill 4,000 years of epistemology into a couple of easy concepts. First off, think about the things that you believe. That's them right there in the green circle. I mean, you might believe you're a good dancer. You might think that your microwave is giving you cancer. You might think that aliens visit Earth. These are pretty typical beliefs, sadly. We all have beliefs in many things, because belief is how we absorb and process all the information that comes in through our senses, and then use that to form an internal model of the universe. Now, that model exists only in our mind, and that as do our beliefs. But this model is extremely useful, because if the model is based on beliefs that match reality, then we can use them to literally predict the future, which is a super handy skill, even if it only works for a short time into the future, maybe minutes to days. Knowledge is a quite different creature from belief, though. The simple way that I look at it is, knowledge is a belief that you can also demonstrate to another person. If you can't demonstrate it, you can't say that you know it. You only believe it. And that's a huge difference. Belief and knowledge are not interchangeable. And people get this confused all the time. They say things like, "Oh, I know that aliens visit Earth." Oh, okay, really? Based on what evidence? Well, I don't have any, but... And see, that's the difference. In order to know something, you have to have evidence for it that you can then demonstrate to someone else. Evidence, just like science, weaves itself into a tapestry that explains a phenomenon. But that isn't how many of us look at it. Now let me explain. We tend to break science up into related categories, like I was talking about with the classes that we take in school. Things like physics, chemistry, astronomy. However, I think this gives people the wrong impression that these subjects are completely different and not at all related. I mean, we all have this idea that chemistry deals with, chemicals, but it has nothing to do with astronomy, right? But that's the thing. All of science is interconnected. Knowledge that we gain in one aspect of science often informs our discovery in other fields. Now let's go back to our example of chemistry and astronomy, completely, seemingly different subjects. Well, let's take a look at how they're connected. Chemists first started compiling a list of the most basic chemicals you can get, the base chemicals that make up everything. We call these elements, and we now have a funny little table of all of the ones we know about that hangs in pretty much every science classroom around the world. It's called the periodic table of the elements. Now, physicists notice that when you take light and you scatter it in using something like a prism, you get this lovely rainbow spectrum. But they notice something else. If there happens to be a cloud of vaporized gas, specifically a cloud of gas that's all one element, like, say, sulfur, then you get these absorption lines in that spectrum. These absorption lines, it turns out, are particular to each individual element on the table. They can actually be used to identify what element is in that gas cloud. This is how spectrometers work that you might see on shows like CSI, where they're actually determining the chemical composition of something. Now, the interesting thing is, if you heat an element, you also get bars of spectrum, but these are emission bars. They end up being bright bars in a black field. And they each have their own, again, unique footprint to the particular element that's being heated. Now, astronomers took these two observations from chemistry and physics and realized that if they looked at the spectrum of light coming from a distant star, they could tell what these stars were composed of. They could tell what chemical elements were in that star. These completely, seemingly unrelated discoveries in physics and chemistry actually informed a third discovery in the realm of astronomy. And even a fourth, because by observing that stars that are moving away from us tend to have their bars shifted down towards the red. This is what's known as redshift. Scientists were able to determine how fast these objects were moving away from us, which was a discovery that led us to understand that the entire universe is expanding and that this expansion is increasing. We wouldn't know that the universe was actually expanding if we didn't know the properties of the chemicals down here. Now, the interesting thing is there are people who want to ignore single elements of scientific knowledge, and sometimes entire fields. Some do this for nothing more than good old-fashioned charlatanism. They just want to sell you their particular brand of snake oil and boogie out of town on the next train. Others do this because certain scientific discoveries are inconvenient to their pre-existing worldview. This is where the whole idea of alternative facts comes from. And it's a major problem, and it's one of the reasons why I started this show. You can't throw out a single discovery without it having ramifications on all of the other fields that are related to it in this gigantic spider's web of interconnections we have. If you throw out biology, then you throw out a good chunk of geology. If you throw out chemistry, you throw out physics and astronomy, as I've already demonstrated. Everything is interconnected in science. So over the course of this series, I'm going to be doing my best to teach you the skills you need to discern fact from fiction. I'll be showing you tips that you can use in your everyday life, and I'll be showing you how your own brain can mislead you. I'm not going to be teaching you what to think. This isn't an opinion or politics-driven show. Rather, I'm going to be showing you some tips that I have found have been immensely helpful in my own life for being a more skeptically minded person. And one of the key tips that I'm going to teach you is how to investigate dubious claims quickly and accurately. Coming soon, we will be covering things like scientific terms, an introduction to statistics and how they can be used to lie to you, some basic short courses on chemistry, biology, physics, just little brief refreshers, and so much more. The point of this series is to help you understand the world around you and make you less likely to fall for pseudoscience and charlatanism. Now, before we wrap this episode up, I have a little homework for you to do. Periodically, I'm going to be asking my listeners to do some basic, brief little science experiments at home, just so that you can understand better how the scientific process works. None of these will be very costly or time-consuming, but I think they really help you understand what it is that scientists are actually doing in the lab. This week's experiment, if you want to call it that, is all about data. See, when we work in the lab, it's all about acquiring data. You need data in order to do some analysis and then finally draw a conclusion. And this is actually one of the more challenging parts of many scientific endeavors, is actually going out and collecting the data. So that's what we're going to do this week. Simple, stupid little thing. All you're going to need for this is a thermometer, specifically the type of thermometer that measures air temperature. You can find these at your local home improvement store or even places like Walgreens that you can just hang on the wall and it'll tell you what the air temperature is. Alternatively, you can use the dashboard outside air temperature gauge in your car if you happen to have one. All we need is a way to measure air temperature. And all I'm going to ask you to do is, for 5 days, I want you to take 2 measurements per day. That's it. You're going to have a total of 10 measurements. I want you to take 2 measurements at different times a day. It doesn't matter really what time of day. You can do 1 at lunch, 1 after dinner, 1 in the morning, 1 in the evening. As long as they're spaced out by a couple hours, it really doesn't matter what time of day you take these measurements. But I want you to be consistent in when you take them. So choose wisely and pick a time of day when you know you'll be able to write these down. Second, I just need you to write down the date, the time you're taking the measurement, and what the temperature is on the thermometer. I want you to do that twice a day for 5 days for a total of 10 data points. And we're going to take these data points and we're actually going to compile them for use in a future episode on scientific statistics. So once you've got your 10 data points, I want you to email them to me at factbasedliving@gmail.com, and we're going to compile these into a data set, and again, like I said, use them on a future episode. Also, I'm going to give you a little motivation to do this, because I'm going to randomly select out of everybody that submits and pick 2 people to get a special science-related gift from me. So go ahead, collect your data, get it into me as soon as possible. I'm going to put a timeline of a month on this just so that we have plenty of time and nobody's playing catch-up. And then we'll just go from there. Well, that's it for this episode. If you liked this video or you hated it, give us a thumbs up or a thumbs down below. Any questions or anything else? Well, that's what the comments are for. Also, I plan on doing periodic special Q&A episodes to answer any questions or address any complaints. So if you have any questions for me or you have any comments on this video that you want me to address, go ahead and leave them in the comments below, or you can always email me at factbasedliving@gmail.com. Well, that's it for this episode. Stay sciencey.